Okay, now we're going to be looking at a 10-inch cylinder separated by half an inch or so, a 3-inch to a 2.5 inch. And on the RCB process, we got 21.3 volts going in, 1.69 going, pardon me, 1.7 amps into the process, splitting into 1.3 amps on the back coil and 1.56 amps on the front coil. Now this peculiar arrangement here of our secondary reception can be shown. We can look at these 3 meters. And what I'm going to do is bring the other primary into action and show what happens when we engage both primaries instead of just a single one. Here's the condition of the shorted plug. We're trying to see all 3 amps meters at the same time. There's 31 milliamps on the front coil and only 3.6 milliamps on the back coil and 32 milliamps through the shorted plug. And then the conditions then when the short is removed, we got 18.94 amps. Now in the unshorted condition we replace the primary onto that coil. Well, of course that's going to double the action, and there's the result of the doubled action, and there's the result of the short, and we got 5.4 milliamps going through the plug versus 28 and 33 there. I found that on this experiment that we want to run up to 120 volts, that if both coils are engaged, we get a 10 amp overload on the variac. So we'll take this coil back up and quickly show the conditions going up to 60 volts, pardon me, and 120 volts, and showing the action of the cell, one cell of distilled water. Currently a little over 20 volts. We go up to 60 quickly. There's a 60 volts, the secondary action. Note that the uninducted coil has 42 milliamps, which is 54, and a small amount going through the output plug. Fairly stable neon discharge if the camera can see it. And then we want to look again on the input conditions. We got 61.6 volts, enabling 4 amps, splitting into 3.4 amps, 4 amps onto the primary over there, combining into 5.8 amps into the rectification and 5 amp electrolyzer action. From here we're going to wait till we go up to a 10 amp electrolyzer action to show the distilled water, and that'll be the end of this video. But we will note the secondary differences here also. That's 120 volts. So we got 120 volts, enabling 6.66 amps. With my good number, right? There's almost that much amperage going on the back coil, and there's 7.59 amps going into the front coil. And then that combines to 1147 amps, enabling 10.25 amps to go through the cell at 27 some volts. 33 volts inputted on the outside. And Miss Kitty has arrived again. We try to keep her separate, but go ahead and try to focus on our cell action and show that quickly so we can... let's look at the secondary real quick then action. At the higher level, we only have 25 milliamps going through the plug. We have a great circulation of 90 milliamps on the back and 103 on the front. And then we look at the action of the cell, and that's about it for that video. See if you can try to get any action there. As we're looking at the bubbling. You put the camera straight over it probably, that's what I did. So there it is, folks. Distilled water electrolysis. It's not as efficient, but it's impedance matched. So this is using the resonant current ballasting technique at 120 volts, yielding 10 amps for the wall at just a 1 there. And that's it. Short down there. Miss Kitty made a momentary appearance, but didn't remarkably disturb me today, so we might be keeping the barnyard cat for a while as well behaved. Get a shot of Miss Kitty, or Mr. Kitty. Here's Mr. Kitty, the famous cat that has not yet got electrocuted. Boy, we worry about the... Okay, that's it.